Hi friends. Today, I will discuss how to calculate dasymetric population density and prepare a dasymetric population density map. At the end of our discussion, I will explain the difference between a normal choropleth map and a dasymetric map. I would like to clarify that all calculations will be based on the binary method. Here's a brief overview of the binary method. The binary dasymetric procedure, described by Langford and Unwin, calculates population density by dividing the number of inhabitants in inhabited areas by the area's size. Its main advantage is simplicity, requiring only reclassification of land cover into inhabitable and uninhabitable classes. However, this method's downside is the subjectivity involved in reclassifying areas based on land cover. Let's get started. Friends, for this study, I have chosen Mosuni Island, which is divided into 4 villages. The information provided includes the total population and total area of the villages. Remember that ancillary data, such as land cover data, are needed for the calculation of dasymetric density. This is the classified land cover map of the island, collected from the ArcGIS Land Use and Land Cover database. See the land cover map. There are 4 classes such as water, forest and vegetation, agriculture, and built-up area. We know that, according to the binary method, all the land cover classes should be reclassified into 2 classes as inhabited area and uninhabited area. Now, using semi-automatic classification in QGIS, I have reclassified the land cover classes in the following way. Here, agriculture and built-up area classes have been established as inhabited areas. After that, only inhabited areas will appear. Then find out the area of the inhabited area class concerning each village. For this, first, select the village, then click. In this way, inhabited areas will be delineated one by one for each village. Then calculate the area in square meters of the inhabited area of each village as follows. I now have information about populated areas in the villages where people are concentrated. Now, open Excel, create a table, and fill it in as directed. Finally, the Dasymetric density will be calculated by dividing the total population of each village by its inhabited area. All 4 villages are categorized into 3 density categories: less than 800, from 800 to 1000, and more than 1000. Now coming into mapping. Begin by obtaining the inhabited area map and tracing its outline. Next, overlay the traced polygon onto the village map. Finally, assign a color tint based on the density category. Create an index. The white box in the index indicates areas with no population. Finally, we made the Dasymetric population density map. If you compare between normal choropleth map and Dasymetric population density map, just put the population density calculated conventional way, then see it will cover whole area of villages. But in the Dasymetric population density map, distribution of density will be only in the inhabited area. See the difference. Lowest population density in the choropleth map observed in the village Mosuni. Highest population density observed in the village Bagdanga and Baliara. However, lowest Dasymetric population density observed in Kusuntala, and highest value observed in the Baliara village. This is the actual distribution of density of population that may help to take decision for disaster management. Thank you for watching this video. If this helps you, please comment, share, and subscribe this channel.